Yes, students, this is the continuation of previous video, which is the concept Introduction to Maxima Minima from Applications of Derivatives, class 12th Mathematics. Let me revise the things which I discussed, the concepts. First derivative test. Very carefully listen. See, the very first one, what is here? The first derivative test. The first derivative test is by taking f dash of x is equal to 0. Then you find out all the points where f dash of x is 0, which are called critical points. What are these critical points? Once again I am reminding, these points are called critical points. Then after finding the first derivative test, you will have to find out the second derivative test. In the second derivative test, the very first step is you have to find out f double dash of x. After finding f double dash of x, in the first derivative test, here whatever the points you got, those points you substitute in this. That is c1, c2, c3 and so on, c1, c2, like that I wrote. Now that is, I am just striking a ci. I means what? It is 1, 2, 3, like that. Right? So for any ci, if you take f double dash of ci is equal less than 0, negative, then f of ci is local maximum. If f double dash of ci is greater than 0, then f of ci is local minimum. If it is equal to 0, the case is different. In the second derivative test, f double dash of ci is equal to 0, I cannot say directly whether it is local maximum or local minimum. I will have to go one step ahead. What is that? See, after the first derivative test, second derivative test, in the less than, it is maximum, greater than, it is minimum, equal to 0, it will happen like this. We will have to go back and see the nature of f dash of x. Nature of f dash of x, I am saying. It is not nature of f of x. Nature of the first derivative f dash of x at ci. So if f dash of x, if it is changing from positive to negative, local maximum. F dash of x, if f dash of x changing from negative to positive, it is local minimum. If you want, you can see the example I have given for x power 4 in the previous video. You can see that one. If it is changing from positive to negative, if it is changing from positive to negative, local maximum. If it is changing from negative to positive, which is f dash of x, it means what? F dash of x, it means what? F dash of x, negative to positive, local minimum. If there is no change in the sign, if there is no change in the sign, this is very important. This may face, if we may face this one. If there is no change in the sign, then x is equal to ci is called the point of inflection where f of x has neither maximum nor minimum at ci. Hope you got it. So that means there is no sign change, means either it may be like x square, x power 4 format will come. That time the sign change will not be there. In the f double dash of x, x square, x power 4 will be there. That time there is no sign change in that, because the squares and power 4s will have positives only. Okay, there is no sign change. So then that is what? There is no sign change, then you can say that it is point of inflection where f of x neither maximum, having neither maximum or nor minimum. Okay, next, in case that is done, first derivative test and second derivative test, that is revision. And now in case, one more is here. In case only one critical point, you can, if there is only one critical point, then when you solve f dash of x is equal to 0, you got x is equal to only one point, only c. X is equal to 1, x is equal to 2, x is equal to pi by 4, x is equal to pi by 3, like that. Only one critical point if you get, directly you can state, you can use the words maxima or minima instead of local maxima, local minima, according to less than 0, greater than 0. Try to understand. If you get only one critical point, you can directly state that f of x has maxima or minima according to that f double dash of x less than 0, greater than 0. That means here you should know, you don't need to use local maxima, local minima thing, because there is only one critical point. That means either it is like downward parabola or upward parabola. That time what happened here? Only one critical point, it is minimum, here it is maximum, here maximum, whereas it is minimum here. Okay, next, let me start with exercise 6.5 questions. Start with exercise 6.5 questions. See that the very first question they are asking, look at the textbooks, take your textbooks, exercise 6.5, the first question, it is page number 231 in your NCERT textbooks. Find the, look at the first line in the exercise 6.5, find the maximum and minimum values if any of the following functions given by. That means if there is any maximum or minimum values, then you should have find out. They are not telling you to use differentials. If they ask you to use differentials, you should go for first derivative test and second derivative test. If they are not asking, you can do by whatever the methods you know. Here I used very simple techniques to do these questions. Okay, look at this. What is that? First question, f of x is equal to 2x minus 1 whole square plus 3. We know very well the square of any algebraic expression is always greater than or equal to 0. So 2x minus 1 whole square always greater than or equal to 0. So for this equation, add 3 on both sides. 2x minus 1 whole square plus 3 greater than or equal to 3. Means a particular function f of x, because this is nothing but f of x. Understood? This is nothing but f of x. No? That's why I substituted f of x here. Greater than or equal to 3. That means f of x value is either 3 or more than or equal to 3, means f of x has minimum value, which is 3. F of x is either 3 or more than 3. That means f of x has minimum value, that is 3. That is the first question. Hope you got it. Now, second question. So before you do the second question, just do the completing square. F of x is equal to, given question is f of x is equal to 9x square plus 12x plus 2. So I just did the completing square method, 3x whole square plus 2 into 3x into 2 plus 2 square minus 2 square plus 2. So that I can group this one here to here. I can group them as a square plus b, 2ab plus b square, which is a plus b whole square formula. So that I can write is 3x plus 2 whole square. So this one, particularly middle term, is very important in writing. So this 12x, no? First 9x square, look. First 9x square was expressed as 3x whole square. Then 12x I wrote as 2 into 3x, as a square is written here. So 2 into 3x into 2, because to balance it is 12x, no? So it is 2 into 3x into 2. So plus 2 square minus 2 square to make the format a square plus b square plus 2ab format. So it is 3x plus 2 whole square minus 2, because calculation was happened. Minus 4 plus 2 is minus 2. And this whole thing is a minus a plus b whole square. So which is always greater than or equal to minus 2, because it is square, no? Greater than or equal to 0, which is always greater than or equal to minus 2. So the minimum value is minus 2. What is the minimum value? Minus 2. The next thing is f of x is equal to minus of x minus 1 whole square plus 10. You know very well. X minus 1 whole square is always greater than or equal to 0. As it is negative, minus is there, means you should put less than or equal to 0, because negative value is always less than 0. So square will be positive, so it is always less than or equal to 0. Understood? So minus of x minus 1 whole square is always less than or equal to 0. Adding 10 on both sides, minus x minus 1 whole square plus 10 less than or equal to 10. Means that f of x will be less than or equal to 10. Why f of x? Because the minus of x minus 1 whole square plus 10 we got f of x. So f of x less than or equal to 10. So maximum value is 10. Hope you got it. Maximum value is how much? 10. The reason is f of x we got either less than 10 or equal to 10. That means f of x will not exceed more than 10. So the maximum value is 10. The next fourth question, look at this. G of x is x cube plus 1. Here I go for first derivative test and second derivative test. The reason it is x cube plus 1. I cannot say x cube can be positive, negative, 0. That is the reason we have to use the first derivative test. G dash of x 3x square, which is equal to 0, because first derivative test is telling the first derivative is equal to 0, we should take x is equal to 0, we got. G double dash of x is 6x, so 6 into 0 will be 0. It is in the third case of second derivative test. Second derivative test, 3 cases: less than 0, greater than 0, less than 0, maximum, greater than 0, minimum, equal to 0. We'll have to check inflection point. There is, and the sign of g dash of x has no change because of 3x square. Sign of g dash of x no change because of 3x square. X square is always positive, there is no change. at x is equal to 0. So therefore it is a x is equal to 0 is a critical point. It becomes point of reflection. Okay, so for f of x has neither maxima nor minimum values. Understood? Next, you can say even instead of critical point you can use point of reflection also. Next, second question. Look at the second question, page number 232. Find the maximum and minimum values, if any, of the following functions given by. Same, instead of squares they used modulus and some trigonometric functions in these questions. So the very first question, f of x is equal to modulus of x plus 2 minus 1. Modulus of x plus 2 minus 1. If I take this one, x plus 2 whole square, modulus of x plus 2 is always greater than or equal to 0, since modulus function is always non-negative. Non-negative means it is not negative, means it is either 0 or positive. That is why we took modulus of x plus 2 is always greater than or equal to 0. Adding minus 1 on both sides, we get modulus of x plus 2 minus 1 greater than or equal to minus 1. But this is f of x. So f of x less greater than or equal to minus 1. That means what? F of x value is either minus 1 or more than minus 1. That means it will be having a minimum value, it is minus 1. Which is minus 1. Next, second question. Same. G of x is equal to minus of modulus x plus 1 plus 3. So as modulus is always greater than or equal to 0, modulus is always greater than or equal to 0, minus mod x plus 1 is less than or equal to 0. Adding 3 on both sides, minus modulus x plus 1 plus 3 less than or equal to 3. Next, this is nothing but f of x. So f of x less than or equal to 3. What is f of x less than or equal to 3 means? Either 3 or less than 3 means f of x has maximum value which is equal to 3. Next, third question, which is h of x is equal to sine 2x plus 5. We know very well the sine function is always lies between minus 1 and 1. Minus 1 less than or equal to sine 2x less than or equal to 1. Adding 5 on throughout the equation, minus 1 plus 5 less than or equal to sine 2x plus 5 less than or equal to 1 plus 5. That means it is 4 less than or equal to h of x less than or equal to 6. That means 4 is the minimum value, 6 is the maximum value. Hence found for the h of x minimum is that, maximum is that. Okay. Similarly, next, f of x is given modulus of sine 4x plus 3. Again, minus 1 less than or equal to sine 4x less than or equal to 1. Adding 3. Why adding 3? Because it is plus 3 here. So adding 3 throughout in equation we get like this. Minus 1 plus 3 less than or equal to sine 4x plus 3 less than or equal to 1 plus 3, which is 2 less than or equal to sine 4x plus 3. It is sine 4x plus 3 modulus. Correct. Okay. Less than or equal to 4. So then we get, this is 3 mod. So then we get like this. When you apply mod, see 2 and 4 are positive, no problem at all. So sine 4x plus 3 value minimum is 2, maximum is 4. Okay. Next, the correction you should make, it is plus 3, it is also plus 3. The correction, please make a correction in your notebooks. Next, fifth question. h of x is equal to x plus 1. It is a linear expression. H dash of x is equal to 1. Means first derivative itself it is failing. H dash of x, when sir, h dash of x is equal to 0, we get some x values, that is fine. But h dash of x is equal to a constant which is not equal to 0 when I get. That time we directly state that the function which will not have any maxima, any minima, any point, critical point, because there is no turning points, because it is a straight line, linear expression. The derivative of the linear expression only the constant. So you can directly state this function has, which is h dash of x is equal to 1, which never be 0. So the no critical points exist. H of x has neither max nor minimum. But the thing is, the question, if you look at the question, look at the textbook. X belongs to open interval minus 1 comma 1. Question number 2, 5. X belongs to open interval minus 1 comma 1. Means what? Minus 1 less than x less than 1. They gave us x plus 1 as the function. So adding 1 throughout the equation. Then 0 less than x plus 1 less than 2. So exactly if you say that there is no maximum, no minimum for this one. But approximately if you say that 0 is the minimum, 2 is the maximum, approximately. Because equal to signs are not there. if they give instead of the interval, if they give like this, or closed interval, instead of this like this interval, if they give this interval, happily you can say that maximum is 2, minimum is 0, because you should use this one, 0 less than or equal to f of x less than or equal to 2 will come, equal to symbol will be there, right? So we can say that, state that time, but open intervals are there, that's why it has no maxima, no minimum values. Okay, next, third question. Look at the textbook. Find the local maxima and local minima if any of the following functions. Find also the local maximum and local minimum values as the case may be. That means if there is a case that maxima and minima if exist, we will have to find out. See that first question, f of x is equal to x square. You can try that question yourself because it is easy, like the first model only. Derivative only, you do find out the derivative, otherwise x square is greater than or equal to 0. You can say first question is f of x is equal to x square, so x square is always greater than or equal to 0, so it has minimum value which is 0. Done, that's all. To say whether it is maxima or minima, because local maxima, local minima terminology used, do the first derivative, second derivative, no problem. If you wanted to do second derivative, first derivative also you can do, because they ask you to tell whether local maxima or local minima. So that means you should do first derivative and second derivative. That means how? Take f of x is equal to x square, f dash of x is equal to 2x is equal to 0, x is equal to 0, f double dash of x is equal to 2, which is greater than 0, so it is local minimum. Double derivative greater than 0 means local minimum, which is equal to at x is equal to 0, where it is at x is equal to 0, so then it is 0 square, answer is 0. That's all. That is the first question solution. Like this is the first question, you can try yourself. Next, g of x is equal to x cube minus 3x. First find out g dash of x, which is 3x square minus 3. First derivative test. G dash x is equal to 0. 3 of x, 3x square minus 3 equal to 0. 3x square is 3, x square is 1, x is plus or minus 1. Now let us go for double derivative. See, which is g dash of x is this one. From here to here, g double dash of x is 6x. So first x values, critical points are plus 1 and minus 1. Take plus 1. G double dash of 1 is 6 greater than 0. So g of 1 is local minimum. Because first second derivative greater than 0 local minimum, less than 0 local maximum. Second derivative greater than 0 local minimum, second derivative less than 0 local maximum. So then it is like local minimum will be g of 1 is the local minimum because x is equal to 1. Find out that. Because g of x is given x cube minus 3x. In that we have to substitute. We got it. X is equal to minus 1, g double dash of minus 1, minus 6 is coming less than 0. So g of minus 1 is local maximum. So find out g of minus 1, which is local maximum. Substituting minus 1 in the g of x. Next question. H of x is equal to sin x plus cos x. H dash of x is equal to 0. Because first derivative test, cos x minus sin x derivative, cos x derivative minus sin x is equal to 0. Cos x is equal to sin x, so which is possible at x is equal to pi by 4, which is in between 0 and 90 degrees. So x is equal to pi by 4, which is 45 degrees, in between 0 and 90 degrees. So now double derivative, yes, double dash of x is equal to minus sin x minus cos x, because first derivative, what is the first derivative? This is the first derivative. Unka derivative is here, minus sin x minus cos x, which is the h double dash of pi by 4, because critical point we got x is equal to pi by 4. Substitute x is equal to pi by 4 in the second derivative to do the second derivative test. Minus 1 by root 2 minus 1 by root 2 is always less than 0. That means second derivative less than 0 means h of pi by 4 is local maximum. So h of pi by 4 find out and simplify, you get like this. Fourth question. F of x is equal to sin x minus cos x between 0 to 360 degrees. Between 0 and 360 degrees. 2 pi means 360 degrees. F dash of x. Sin x derivative cos x minus cos x derivative is plus sin x, which is equal to 0, which is first derivative test. Cos x is equal to minus sin x. Means what? Cos and sin are equal, but they are opposite in sign. So cos and sin are opposite in sign is possible in quadrant 2 and quadrant 4, because in quadrant 2 sin is positive, cos is negative, but in quadrant 4 sin is negative, cos is positive. So they are in opposite sign in quadrant 1 and quadrant 2 and quadrant 4. Same sign in quadrant 1 and quadrant 3. They are having same sign in these two quadrants. Because in quadrant 1 all are positive, so sine and cos positive. In quadrant 3 all tan and cot are positive, so sine and cos are negative. So that concept was used. So cos x is equal to minus sin x is possible when it is quadrant 2 and quadrant 4. Quadrant 2 angle is pi minus pi by 4. Quadrant 4 angle is 2 pi minus pi by 4. Why pi by 4 was taken? Because cos and sin are equal at 45 degrees, which is 1 by root 2. But they are in opposite in sign because the cos x is minus sin x. That's why pi minus pi by 4 in quadrant 2, 2 pi minus pi by 4 in quadrant 4. So 3 pi by 4 and 7 pi by 4 are the values of x. Now let us go for second derivative test. F double dash of x. Where is f dash of x? Look at that first. The derivative of this will be minus sin x plus cos x, because cos x derivative minus sin x derivative plus cos x. Now the points, critical points what we get, we use. What are the critical points we got? Here is the critical points. So x is equal to 3 pi by 4, f double dash of 3 pi by 4 we find out minus sin 3 pi by 4 plus cos 3 pi by 4. In second quadrant sin is positive, so minus 1 by root 2. Cos 3 pi by 4 is minus 1 by root 2, because in second quadrant sin is positive, cos is negative. So it is already minus sin 3 pi by 4, so minus 1 by root 2. So cos 3 pi by 4 is minus 1 by root 2. So minus root 2 is less than 0. Next. So when second derivative is less than 0, f of 3 pi by 4 is local maximum. F of 3 pi by 4 is local maximum. Now similarly the another critical point, find out f of 3 pi by 4 by substituting f of x in f of x. This is f of x, na? In that you substitute f of 3 pi by 4. So in this f of x you substitute f of 3 pi by 4. Where is 3 pi by 4? This is like this. Then you get root. Similarly x is equal to 7 pi by 4, substitute in the second derivative, so that you get root 2 greater than 0. 7 pi by 4 is in fourth quadrant. Fourth quadrant sign is negative. So minus sin 7 pi by 4 is plus 1 by root 2, because negative of negative positive. Cos 7 pi by 4 is plus 1 by root 2, because in quadrant 4 cos is positive. 1 by root 2 plus 1 by root 2 is root 2 greater than 0. Second derivative is greater than 0, so local minimum. F of 7 pi by 4, find out the value, then keep it over there. That's all. Next, fifth question. F of x is equal to x cube minus 6x square plus 9x plus 15. So f dash of x is equal to 3x square minus 12x plus 9. So which is 3 into x square minus 4x plus 3. I derivated and I just taken 3 common. Then 3 into x minus 1 into x minus 3, how we got by factorization. Take f dash of x is equal to 0, then x is equal to 1 or 3. Now two critical points we got. These are the two critical points. F double dash of x is find out by using the first derivative. By using the first derivative, from there to here you find out the second derivative, 6x minus 12. Now using these two critical points, go for second derivative test. At x is equal to 1, f double dash of 1 is minus 6, which is less than 0, because here substitution was happened. Because 6 ones are 6 minus 12 is equal to minus 6 less than 0. So f of 1 is a local maximum. So find out f of 1 which will come 19. Similar way you go for finding at x is equal to 3, because two critical points. F double dash of 3, substitute in this. So plus 6 will come greater than 0. So f of 3 is a local minimum. So find out that value by using the calculation in substitution with f of x. X is equal to 3 in f of x, substitute it. Then you get local minimum. Next, sixth question. G of x is equal to x by 2 plus 2 by x, where x greater than 0. Then what is g dash of x? X by 2 ka derivative is 1 by 2. 2 by x ka derivative is minus 2 by x square, because 1 by x derivative minus 1 by x square. So g dash of x 0 you take it. Then solve for this. You get x square is equal to 4. X should be plus or minus 2, but we take only 2. We take only 2, reason x greater than 0. Right? Look, now second derivative. First derivative x is equal to 2. G double dash of x we have to find out first of all. 4 by x cube. because 1 by 2 का derivative 0, minus 2 by x square का derivative plus 4 by x cube, because minus 2 by x square, use the method minus 2 into x power minus 2, minus 2 into minus 2 x power minus 3, 4 x power minus 3, which is 4 by x cube, which is 4 by x cube. So g double dash of 2, because critical point x is equal to 2 we got. G double dash of 2 is 4 by 8, which is 1 by 2 greater than 0. So g of 2 is local minimum. Find out the g of 2. That's all, which is 2. Next, 7th question. G of x is equal to 1 by x square plus 2. G dash of x you find out minus 1 by x square plus 2 whole square into 2x by chain rule. By where? Chain rule. G dash of x is equal to 0 you take, then x will be coming 0 if you solve it out. And g double dash of x you find out now by using u by v rule, by taking this one as minus 2x by x square plus 2 whole square, u by v rule, use it and solve it out. After doing g double dash of x, here directly substitute x is equal to 0 in the g double dash of x, so that you get second derivative test. It will be less than 0 will come. Substitution I have done. So therefore g of 0 is local maximum. What is g of x? Substitute. In the g of x, 0 substitute, that is local maximum. That is 1 by 2. Otherwise, alternate method, g dash of x, what we got? At x is equal to 0, this derivative is then, this first derivative has a sign change, negative to positive. Because 0 before, if I put negative, positive to negative, sorry. It is positive to negative. Because x equal to 0, when it is before 0, negative will come, negative into negative positive. After 0, positive will come, negative into positive, negative. So there is a change in positive to negative, so local maximum. Positive to negative means local maximum. That is the, I can say one more method, that method. Nature of first derivative. Based on that, local maximum, that is g of 0, which is 1 by 2. Otherwise, you can do the second derivative test also. Next question. 8th one, f of x is equal to x into root over 1 minus x. See, this method, whatever I did it, because to avoid the root, I used one method here. What is that method? Look at this very carefully. F of x is equal to x by x into root 1 minus x, x greater than 0. So then I squared it, so that x square into 1 minus x whole square, which I assumed that one as h of x, x square minus x cube by multiplication. Done. Then I do find out for h of x. H of x I do everything, first derivative test, second derivative test, and or for h of x we will do. H dash of x is 2x minus 3x square, because for this. H double dash of x is 2 minus 6x. I found all. H dash x 0, first derivative test. So x value will come 0 or 2 by 3. But x greater than 0, they said. We don't take this value. We take only 2 by 3. So in double derivative, whatever we got double derivative, in the double derivative 2 by 3 value substitute. H of 2 by 3 is equal to 2 into minus 6 into 2 by 3. It is coming minus 2, which is less than 0. So h of x has local maximum at x is equal to 2 by 3, because second derivative is less than 0. So this is h double dash, correction. Understood? That is h double dash. This one, correction is there in the book. Notes. This is correction. H double dash of 2 by 3 is negative. So h of x has local maximum at x is equal to 2 by 3. So f of x has local maximum at x is equal to 2 by 3. Therefore, h of x is having local maximum, means f of x is also having local maximum at x is equal to 2 by 3. So f of 2 by 3 we require, that is 2 by 3 root 3 will come, because it is x root 1 minus x, which is always positive, because they said x greater than 0. If they don't say x greater than 0, you will have to do for f of x only. So when you are taking x greater than 0, this is always positive only. So positive can be squared and found, no problem. If there is no x greater than 0 condition, you cannot take h of x by squaring. So there is h of x greater than 0, that's why we are taking. Okay. So then now we get it the answer. Since h of x is having maximum at x is equal to 2 by 3, f of x is having local maximum at x is equal to 2 by 3, f of 2 by 3 we found, and we got 2 by 3 root 3. Now look at the fourth question. What is the fourth question? Prove that the following functions do not have maxima or minima. Very easy. See, f of x is equal to f dash of x is equal to 0. F dash of x is equal to 0. So derivative of e power x is e power x. In the first question, if you look, it is e power x. So derivative of e power x never be 0. Remember, there is no such x belongs to R. So f of x has neither maxima nor minima. That means we are not getting the x values. Similarly, g of x is equal to log x. G dash of x is 1 by x. 1 by x is also never be 0 for any x. So g of x has neither maxima nor minima. H of x is equal to x cube plus x square plus x plus 1. H dash of x is 3x square plus 2x plus 1. This is also never be 0 for any x as discriminant is less than 0. That means imaginary roots. There is no real numbers such that this is become quadratic equation. That's why when discriminant less than 0, we don't get any real x. We get imaginary x. Roots are imaginary. That's why there is no real x. That is the reason discriminant is less than 0. There is no real x. That is the reason h of x has neither maximum nor minimum. Try to remember. Okay. That's all about this chapter 6, note 6. And I explained in this. I just revised all the concepts which are based on the maxima, minima, basic concepts and the basic algebraic questions and some trigonometric questions and some what and all algebra. In the algebra, algebraic questions, trigonometric questions and modulus questions was explained, and sometimes some questions related to maxima, minima, local maxima, local minima, absolute maxima, absolute minima questions also explained. So try to understand the previous video which I sent you. That video is about the introduction. Most explanation of maxima, minima was given over there. I was explained graphically, algebraically, and problem solving also I explained. First derivative test, second derivative test was explained very clearly in that. Even in this video also explained first derivative test and second derivative test properly. Once again I revised. So this concept is very important. It will come for exams, and in the board examinations you can expect a 6-marker question from this concept. So get ready. After this video, you are going to watch a video which is the most expected 6-mark question, which is application type questions in these applications of derivatives in maxima, minima concept, which most of the students feel tricky in this one only. So get ready with these two concepts. If you are strong in these two concepts, you will understand application questions also very easily. For the applications questions, you must be ready with all mensuration formula which were there in 9th and 10th standard about cone, sphere, cylinder. What is volume, surface areas of cones, cylinder and sphere, and circle, rectangle, those also will come in these applications. So these mensuration type questions are most expected 6-mark questions for the board examinations. So this exercise, after discussion of this exercise, there is 2 more notes, 2 more videos will be there based on this maxima, minima, which are, one is application type questions, another one is extra questions which were given in the previous board examinations. Those 2 are there left. Then this chapter is done, right? So stay home, stay safe everybody. Thank you very much for this opportunity. Thank you so much.